Hello again, everyone. Lovely to see you. Well, if I could see you, it would be lovely. A bit of a strange day today because we've finished differentiation, which means we've got the excitement of integration to go on, which will help me deal with the fact that I'm down to just half a ginger biscuit left. But it's not all doom and gloom. I've found half a packet of cheddars, and I'm sure that'll help fuel us through. So, what is integration? I hear you ask. Well, we have to learn integration just in the same way as many years ago. As soon as you knew how to expand brackets, you needed to be able to factorize to go back the other way. But it has lots of useful applications as well, whether it be calculating the areas of surfaces, finding the volumes of irregular shapes, finding the areas under curves, which has massive applications in mechanics. So today should be a little bit easier than what we've been doing in differentiation for a while, because we're going back to the beginnings of integration. So let's see how you find this. Now, before we start integrating, I'd like you to consider this. What happened when we differentiate these three different functions? Y equals x squared plus 10. Well, hopefully it's not news to you to think that that's going to be y, that's going to become 2x, because we multiply by the power and move the power down by 1, and a constant disappears. Now, if we do the same thing here, we also end up with 2x, and if we do the same thing for x squared minus 7, we also get 2x. Now, if we're going to integrate and go from here back to here, we have a little bit of a problem. So that problem we deal with just by calling it the constant of integration, because this number here, plus 10 minus 7, is known as a constant, because whatever your value of x might change, but whatever it is, you'd always add 10 before finding out what y is. And same here, whatever x is, that will make x squared different, but you will always take 7 at the end. And apart from squaring x, you'll always do nothing here, so the constant there would be nothing. So this term is known as a constant, and in integration we get something called the constant of integration. Okay, now what we've got is a three-step process. For differentiation, we just had these two steps in the other order. We didn't need to worry about this one, but it's not a big issue. So we're starting with the differential is x to the power 4. If we integrate that, we'll get that y is going to be, well, we add 1 to the power, because that's the opposite direction to what we were doing before. And then we divide by the new power. And we've got a choice about how we write that. So dividing by 5, I could write x over 5, or I could have written 1/5 in front of it. So that would be my answer there. On to the next one. If I've got x to the negative 5, when I differentiate that, I'm going to add 1 to the power, so that's going to go up to negative 4. Then I'm going to divide by that negative 4, which I could do as timesing by negative 1/4. And what have I not done? I haven't done the bit I went on about at the beginning, adding the constant of integration. So I need to add c there and add c. I do not need to worry about what that number is, because I can't know at the moment. I'd need some more information. We'll talk about what we do with that in later lessons. But for now, that's all we need. Now I've got one more set of examples, and then it's up over to you. So the other form we can have it in, instead of y equals is function of x, or in this case the f dash of x, because it's been differentiated and we need to get back to where it was from. So we're going to have the function of x will equal, I'm going to add 1 to the power. So if I add 1 to a half, that's going to give me 3 over 2. And then I'm going to divide by 3 over 2. Now dividing by 3 over 2, I've got my 3 there, so 3 divided by 3 over 2 is going to be the same as timesing by 2 over 3, isn't it? And I can cancel those two and it leaves me with 2. So that would give me 2 x to the power 3 over 2. This second one, oh, and I keep forgetting, add the constant. That cost me a biscuit. At the end of my ginger biscuits. Right, hopefully you've got your own so you can reward them if you spotted that mistake. Right, so when we go from here, very simply, if you've got nothing there at all, that's an x to the power of 0, you can imagine that as. So you just need to put the x in and divide by 1. Well, 3 divided by 1 is 3, so it stays the same. Remember, when we differentiate, if you've got x's, you just lose the x, don't you? So it just does the other thing going the other way. And we add our constant. Now the third one we've got here is a polynomial, meaning we've got more than one variety of x. Oh dear, that's my phone going off. I'm not sure what I'm meant to do about that in terms of confiscated or something. Right, okay, so this, we treat each term separately just as we do when we're differentiating. So I'm going to add 1 to the power, which will get me to 2. I'm going to divide 6 by 2. 6 divided by 2. But I'm going to write it all in for now and then do it on another line. That would give me 3, wouldn't it? Now, on this one, the x value is going to go up 1 from -3 up to -2. I'm going to divide 2 by -2. And on the third one here, the power is going to go up 1, so that'll be to 3 over 2 like last time. And then I'm going to have -3, and that's going to be divided by 3 over 2, which I'm going to write as times 2 over 3, just like the one we had before. And I'm going to remember that I've got to add my constant. And then I'm going to clean all this up on the second line. So 6 divided by 2 is 3x squared. 2 divided by -2 is -1, so that's -1x to the -2. 3 divided by 3 is 1, so then that'll clean up like the last one did to -2x to the power 3 over 2 plus c. You may want to watch that one more time to work that out. Anyway, that is all of that, and once you've done that, all we need to do is start practicing integration. There's a whole load of examples for you to have a go at on page 289. I would encourage you to have a go at all of them because they're all slightly different and they all make you think about something. And if you can get this so that you get into the process of this now, when things start getting a little trickier in the next few exercises, you want this skill to be something which is as honed as possible. So page 289, exercise 13a. You have some fun with that whilst I tuck into my packet of cheddars. Thank you very much. Bye bye.